Okay. Um, Topic for the session is continuous integration and testing. This is one of our Agile topics. I'm actually bringing it in a little bit before the sprint in order to, um, so we're kind of going to be ready. We're going to set up continuous integration and testing for you, so I want you to be aware of the concept beforehand. Um, I'm recording this a few hours after the static analysis one, so I apologize for the coughing fit on that one. Pretty funny when I looked at it. So I'm going to try and make this a little faster, and I got a big cup of water trying to prevent from coughing into the mic so much. But it kind of goes hand in hand with static analysis as well as some of the other quality practices we've talked about so far, because we really want to take advantage of automation and the ability to automate several part of our quality practices to keep, again, that rhythm, that cadence, that momentum going in our agile projects. So another technique that's been, not necessarily only for agilists, but certainly has been made popular by the movement toward agile. So again, some questions to think about up front if you want to pause and take a second. Um, but think about integrations that you do every day, and nothing to do with software and computers and so forth. But think about integrations um, that you do every day. So, for example, schedules. Right, I have to sit down with my wife every Sunday night and plan out the week. And now my kids are old enough that I have to do that with their calendars as well. Everybody leads a busy life. You guys certainly lead a busy life. So you guys sit down and integrate calendars, right? I have about 9 different Google calendars that I'm subscribed to between my family, work, Little League, you name it. And your life is probably like that. That's an integration task. Integrating this class into your daily life. Many of you have jobs, you have other classes, you have personal obligations, and so the time that you allocate, another kind of scheduling thing, but that's an integration that you do every day. Um, and you probably revisit it every day, right? That's another thing I should mention. The point of this is these are not just things that you integrate, but things that you integrate potentially every day, your schedule, class into a daily life. What if you go to the buffet line? All right, you eat at a Chipotle, you eat at Fresh Tomatoes, you eat somewhere like that. Um, that's an integration. You get to put together food how you want to eat it. That synthesis activity is integration. Oh, this is going to keep happening. Let's try and make it not. Integrate work and life, another form of class in daily life. Now you've got your job and your daily life, technology into your life. How prevalent is technology now? As you know by taking this class, that integrating that into your daily activities is always a daily challenge. I mean, how much time do you spend rectifying a technology error that you encounter every day? Integrating cooking, that's something one of my students came up with. Every time you cook, you're integrating different spices, different ingredients in a workflow, a recipe type format. So again, actually, that's a good one because some of these integrations are in a sense planned. There's a specification for them, like cooking may potentially be a recipe. Other of them are very ad hoc or reactionary, or as we might say from an agile perspective, empirically driven, data driven. And part of continuous integration and testing, a big part of it, is giving us that constant feedback. So again, back to Super Mario, something we can adjust to every day. Okay. General concept of integration testing before we get to the continuous integration and test. From an integration testing standpoint, you view the entire system as a collection of subsystems, sets of classes or packages, or subsystems in terms of something functional that you assign a responsibility of the overall system to. Usually determined during some kind of design or architecture phase. Um, the order in which those subsystems are selected for testing and integration determines a testing strategy, meaning if you start with the database subsystem, then and you integrate it with, say, a logging routine, a database access routine, a networking routine to transmit data, that's going to dictate part of what your testing strategy is. Also, um, not just the order of testing, but the order of implementation can impact. So you could try and integrate all at once. So you have n number of components or features of a system, subsystems, and you try and put them together all at once. You could start with bottom-up integration, means relatively small implementations of systems, and try and build it from the top up and do it pairwise. In other words, make A integrate with B, make C integrate with D, and then make the results integrate with each other. Kind of build that tree on the way up. From our perspective, that would be building this bigger tree going. There we go, my pen again. That would make integrating our tree in this direction. That would be bottom-up integration. If you're top-down, take this tree and flip it to the right, and you're going from the smaller parts into more components and going top-down. It could be thread-based, meaning you have a lot of times in component-based or subsystem-based computing, when you have subsystem 1 and subsystem 2, they're what's called active components. They'd have a stereotype of active on them in UML terms. And from an active component perspective, they would have their own thread assigned to them. They'd have their own work, their own process assigned to them, some computational resource assigned to them. And therefore, that partitioning of the system may be thread-based or process-based, and therefore you want to integrate doing the individual processes, get them going first, and then when you do the integration, see how that concurrency works side by side. Then there's variations, of course, of the above. So if you're looking at this from this tree perspective that I have here, you may, nothing says that you can't kind of have it both ways and start in the middle. All right, depending again on what your development plan is. The last one to mention on here is this one at the top that says Big Bang integration. If you look back at our software process review slide I was talking about, there was this notion in waterfall of Big Bang integration happening late in the cycle, and things would break very late in the cycle because things wouldn't integrate, meaning everybody kind of did their own functional requirements just fine, but the individual integrations, those individual assignments or specifications of integrations, I should say, those join points between things, that's where things would break. All right, and you wouldn't discover that until you actually integrated it with an actual other component. And maybe the thing that blew up wasn't functional, it was non-functional, like we talked about with dynamic analysis. You put the two components together, maybe they're two concurrent components. Maybe we are talking about A and B up here at the top of this tree, and we put them together, they were all fine individually, but when you went to integrate them, you had a deadlock problem or something like that. So integration testing is quite important, and one of the things that we found is the longer you defer integration testing, the bigger problems that you have. So that's kind of what traditional testing, this is the waterfall diagram again, that kind of left it down here in verification. To do things, you kind of do all the testing here in waterfall, and then all that work for planning, generation, lab, and infrastructure setup, that's all a big investment. So while these things over here are going on, the QA team is all sitting there trying to plan, set up the integration for, set up the environments for doing this verification, and hope to get a return on investment that, setting up all that big scaffolded infrastructure, that you'll pay for it once, not continuously. All right. Now, again, there's some assumptions there. We're back to our change. If you're going to start here in time, planning out for verification while the rest of the team is working on these phases till they get to you, then if there's any change in here, right, it would imply rework. So you're assuming that your test cases won't change, and that your test infrastructure design doesn't have to change as well. The test can be executed periodically thereafter. This means after this in time. You'd initially do it. Again, I make a habit of these slides. So your initial testing or validation steps on these things, right? These things are happening as typically you're going forward in a forward engineered type process, and you get to your testing phase. So initially you're checking that the requirements have been met as part of this, as well as the correctness of the implementation. After this, you're hoping to get periodic reuse of the tests post-release in the maintenance phase through regression tests. So if there's an incremental release, if there's enhancements, if there's bug fixes after it's out in the field, that you could still reuse, and you can save these, save the tests, save these artifacts as part of your release branch. Again, biggest main problem, integration tests would fail, leading to massive rework. In forward engineering, we got down to here, these would fail, and the thing is, where in here do I have to go back to, and how much work am I going to have to do to go around the loop again? All right, in order to fix, and big cost, big time delays, big budget overruns, extremely difficult. So folks want to try and do the integration sooner, try and have some confidence that when they put things together, all right, we talked about managing complexity through decomposition. If they're going to decompose the problem in their design phase into these individual subsystems and then have to put them together, then they want some confidence, more confidence than they were getting, that this is actually going to work. Some techniques would try for that. We talked about formal methods, right? If you have a formal specification. If in unit testing, I talked about one type that I didn't really like to be considered as unit testing, and that was Somerville included interface testing, right? The interface testing, to me, I said it was a form of integration testing, because I want to know that the interfaces between these things, we're going to work out just fine ahead of time. So that again that requires a more kind of big upfront design work in order to do it. Agile is going to take a different approach. Our Agile approach is to think in terms of continuous integration and testing. Instead of waiting to integrate, at the end, integrate and build the system several times a day. Integrate every time a task is completed. When's a task completed? Think GitHub. Every time you push. Okay? Make sure you get an update and let everyone know every day the status of the system. All right, now this wasn't always possible with tools, and in some systems engineering, it still isn't practically possible. But now we have faster build systems. We have incremental compilers and other technologies like that. The web becomes a nice another information radiation source to let the entire team know how things are going. And in general, developers are expected to spend more of their own time testing and spend more of their time automating their tests and more of their time planning out tests at their level. In other words, the testing activity gets spread throughout the life cycle, is not just at the end in this big validation phase. Okay. Back to some of our Agile Kool-Aid. What do we say here at the bottom? If testing is good, why not do it all the time, right? That's kind of the Agile philosophy. If integration is good, why not do it all the time, several times a day, right? If customer involvement is good, why not show the business value and quality we're creating every day? Continuous reporting, right? You already have some of that. That's your Scrum board, right? That's tag it to you. But the CI and test dashboard is going to give the quality viewpoint of that, so we can get our process, how we're gaining business value, but I also will now have a dashboard information radiator for quality, and I'm going to show you some examples of that toward the end of this. Again, with the philosophy, I love the language of Agile sometimes. We'll see some of this language in refactoring as well. But one of the things that Agilists talk about is relentless testing. I love that word, relentless, right? Means you're not going to give up on it. You are going to stay after it aggressively. And so continuous integration goes hand in hand like that. I can relentlessly test every day, and I can continuously integrate every day, and I'm not going to skip it. It's going to become part of my daily automated set of practices. All right. By keeping the system integrated at all times, you increase the chance of catching defects early and improving the quality and timeliness of your product. We talked about this before as well. The time between defect injection, right? Actually, you know how I like to scribble in the white spaces. Let me scribble in a larger white space. The time from defect injection to, all right, delta time from here to defect discovery. If you can take this and rate limit this towards 0, all right, then you are greatly reducing the cost of rework, costs that other folks have done in dependency to something that you've done, all those kinds of things, and therefore you're going to improve the quality. I mean, find and fix your defects as close to possible in time to when you inject them. Drive it from what used to be months down to weeks, down to days, down to hours, down to seconds, if you can, right in your IDE. And again, tooling and automation is helping us with that. Okay, and that's what this is about. From the perspective, kind of a logistical perspective, now we have no separate test phase, right? We're out of the mode of waterfall where we have some tests done here toward the end, and instead we're doing it continuously, right? But there are some drawbacks to that. From a tester's perspective, having a stable set of requirements that they can start building their test plans against and planning out their testing environments makes their life so much easier. But not just your development, but your testing folks, your QA group has to get agile as well. They must be able to adapt. They must be able to embrace that change. So as the features change during the release, the specifications change, they have to change. All right. So just like release planning or sprint planning, testing also starts on projects day one. If you have a separate QA resource, they should be on the Agile team. You have to do some measure of planning for the project up front. It's not that you don't plan or anything else, just like we do release planning, but you have to be more adaptable, and you have to plan to enable change as well. All right. But when we start talking about building every night or several times a day, we start talking about embracing change by adaptively planning, like we do on the Scrum board. When you move the task around, you're adaptively planning and continuously integrating all the time. Well, for most testers, that's kind of a nightmare. Your testers, your QA resources, even if they're not developers in your organization, they need Agile training if you're going to go Agile. But how else can we help this? Well, we can help this through automation. Continuous integration testing is very big on test automation. All right, so we're requiring test automation. Each build must be validated so future integrations build on no quantity. If I'm going to now break down integrations into small incremental steps so they can happen faster, then I have to be bulletproof confident in each individual step before I test the next step. All right. There's a lot of test frameworks out there providing that infrastructure to do unit testing. You've already seen JUnit, XUnit, NUnit, all kinds of unit testing harnesses. We're talking about additional quality tools, static analysis. We'll talk about metrics, things that evaluate your quality on a daily basis. So there's plenty of tooling, I guess is what I'm saying. The key is, one, can you automate it? Two, can it report out? Right? Can it go out to a dashboard? Right? So everybody can see and react. When would you see and react? Hey, guess what? You got a daily stand-up. You run the build overnight. You run the integration and test overnight. The first thing you should check, maybe even before the Scrum board, is you check your dashboard, your quality dashboard, and see what it looks like. See if anybody broke the build. We'll talk about that. There are different levels of these continuous integrations and tests. There could be the developer's delivery to your configuration management. So think about that. What that basically says is, I'm going to have, as part of, we've a bunch of times talked about quality policy. My quality policy before I am able to push something to user story N is that all unit tests pass. I'm not going to let you push it. All right, and maybe code coverage is 70%, let's say. Okay, that's a specification of a quality policy. So the developer can't push to CM is Git here, GitHub, wherever your repo lives, can't until all those unit tests are available and able to be run, and they can be run in an automated fashion. That's why we put it in something like Ant, and we don't worry about it just in Eclipse. In Eclipse, I want to run it in my development environment because that's on my laptop and so forth. Why the heck do I have this thing as an Ant script as well, and why are they different? Well, because the Ant script is what's going to allow me to submit a testing server, if you will, a common place, and get a report back on how my test ran and whether or not it met that criteria. Then if it did, then I'll allow it to go into my repo. Okay, that can be enforced by a human, but even those policies can be enforced now by software scripting that's done on your change management system, on your source code control. You could have something called a pre-commit hook that says, okay, I'm going to go run the unit tests. Hey, that thing doesn't report back that you passed. Guess what? I'm not going to allow it. I'll reject that in the git pull workflow automatically. You may have nightly builds. So this may be developer delivery to source code control. If you're working full time as a developer on a project, you may commit a few times a day, but certainly throughout your whole team, there's going to be several commits to source code control a day, and so these are all automated, all run as part of the build process itself before you're allowed to put it up in your repo. Then normally there's kind of a sanity nightly build across all of the different branches and releases of your software. Usually you try and automate just about every part of that as you can, but these are more integration tests, all right? What we were just talking about, putting those interfaces together and so forth. As you go, since you're integrating, you're putting things together, it's going to be bigger. And as things get bigger, it may be harder to provide 100% automation. You should still strive for it. You may be able to do it. But you may have some limited manual amount of testing, meaning you may have to get a human resource involved, in which case that person's job, maybe that's the last person to leave the building at night. Maybe that's the first person to come in the morning and check last night's build and the automated test, and then to run his or her own tests, and then report to the team at the daily stand-up how the nightly tests went. A lot of times these are smoke tests. Doing full-blown integration, full-blown regression tests may not be practical, so you do what's called a smoke test. Hopefully you've heard of the term smoke test before. If you haven't, it's pretty common sense. They call it a smoke test because where there's smoke, there's fire, right? So the smoke tests are intended to be high-value tests that will generate anomalies at a higher rate, with the expectation that if they generate some smoke, then hey, the developers need to go look at that part of the code to see if there's a fire there and what's going on. All right. There can be an iteration test, so this happens at some measure of your iteration. The quality numbers can be attained automatically, so these things originally were thought of to be done on your sprint boundary, so you could get a data point about the quality numbers associated with teams. So again, you might get your code coverage percentage, you might get reports from your static analysis tool. We're going to talk about metrics in a week. You get all these kinds of reports, and it goes into that baselining that you would do for trying to get a little bit better at this pad. Last time I was talking about, you always want your quality to kind of go up over time. Well, if you do it in a sprint boundary, you may stair step your way up in terms of your quality baselines from sprint to sprint, and you always hope to be getting better. Now, that one says do it on the iteration boundary because it assumes that these things are still expensive operations. I can tell you that more and more you can start doing these things on a continuous basis as well. These tools have gotten better, faster. They are far more automatable than they used to be now, and you can even get those into your pre-commit hooks that I was talking about up here. The question is how much of that do you have the time to pay attention to in the continuous stream of development? Meaning, you'll know when you look at your lab for static analysis, for example. Do you want to stop the world, stop what you're doing, and go through all of the false positives of a static analysis report while you're in stream of development? Maybe not. Maybe that is something you want to defer. Maybe you don't do this kind of stuff every iteration. Maybe you do it periodically every time you take your different user story branches in your GitHub, your Git pull workflow, and bring them into master, right? Maybe it's at this point that you do this. And again, part of the quality policy that a software development team and a software development organization has to decide. There is No recipe for this. You'll go to different organizations. They'll have different best practices. Hopefully they've defined one. If not, go in there and define one for them, because you really need to be doing this stuff as frequently as you can while maintaining the rhythm and cadence of the team. And then finally, milestone iteration. Normally, this is the kind of thing traditionally, milestone means some kind of release planning or something that has customer involvement. Now, again, Agile will say that is the sprint, right? Because we're doing a potentially shippable increment every sprint. But even outside of Agile, the time when you're going to do this is whenever some normally externally visible milestone has been defined, so you can do some of the extra stuff: performance, scalability, stability. I was talking about some of these things with dynamic analysis. Again, this is a best practice recommendation. I still recommend trying to do these all the time if you can. All right, now it can be more difficult to do dynamic analysis all the time because you really need a mirror of your production environment and so forth. There's logistical issues. Again, and I have heard this comment. I know thinking in this way is a little bit different, but there is no formula for it. There is no one agreement on the best time and place to do these. All these activities have a cost associated with them in terms of time, real money, and its effect on a team's momentum and ability to deliver. So as you do more with the time, that's great. The quality will go up too. But are you able to build value at a steady rate, or is building value going to go down on your burn down chart because you're spending way too much time with all these activities? All right. Depends on what you're building. Depends on the domain, the experience of the team, the infrastructure you have set up. No one answer. You would hope that your organization gets better over time at this stuff. Better tooling, better understanding of the things that they need to do. More mature practices. So over time, you can do these things all the time in a set way, and you understand what all the data streams are telling you. Otherwise, you can actually lose benefit. You can actually have a drawback to all this because it becomes burdensome on your process, and the team doesn't feel like it can get anything done. Definitely a balance. Agile best practice, continuous testing. Unit, system, and integration tests can be run continuously. All right, that's what we mean. Oh, I got the erase on. All right, I can run these things continuously. So that does require some infrastructure. You have to have some tooling. You need a build, test, automation, and reporting framework. Your automation framework for building, by the way, that's again why you have Ant. Ant's a very simplistic one. There are certainly other ones out there that have become more popular, but this one, it may not seem it to you, but this is this may be the simplest one out there. Another old school tool would be something like Make. All right, but that's why we talked about that right up front at the start of your project, start of the semester. Reporting framework, though. What's our reporting framework? There's several of these out there that become popular. Here's some screenshots of some ones in the bottom. This is one for IGStick. Was an image-guided surgical toolkit that I was part of an open source project for. It's still out there at igsdk.org. In any event, this tool is called C-Dash, and it produces dashboard style reports. There's one called Rational Team Concert. This is part of the IBM Jazz platform, and this is actually a souped up version of Eclipse, but it has its own dashboard for different quality reports over time. There are additional ones, and so I'm going to jump out here if I can and go show you a couple. All right. Let's say this is the current C-Dash site. Let's see what it has out there in terms of some public dashboards we can look at. Grassroots DICOM. I don't even know what that project is. Hopefully it's got some active things going on. So let's take a look at some tests that had failed. All right, this is a company called Kitware. They have offices in upstate New York, North Carolina, Paris. They worked on IGStick with us. That one's taking a little while to load. While that one's loading a particular test, I'm going to show you another one. This one's called Jenkins. Jenkins is open source. There's a hosted service from CloudBees. This is actually some projects from your course last year. And what a tool like this will do, let's look at Team C Gamers, is this will do, and look at this thing's been running for the past year. Frankly, I kind of forgot it was out there. you can see all the tests going back in time, and these things were set up to run in the middle of the night, all through the past year. And you see at some point, these builds, these are all build numbers or test numbers. Um, uh, there were examples of failures. Red means it failed. All right, the build failed for whatever reason. Reasons, you can go in this tool and look at the console output for what happened in the fail. So this is the run of their Ant script. You can see it has the coverage report from Jacoco and the JUnit that you were doing. Very similar stuff. Find bugs. It's in your current lab for the for static analysis and its property. PMD, which I talked about in the static analysis lecture, but I don't actually require you to use on your report, but it's out there as well. So this is an example of an Ant script that reported something that failed. You can drill down into the individual tool warnings. These plugins on Jenkins give you all kinds of distributions of different things, of what kind of errors and what kind of package, errors and warnings and what particular file. Gives you the types of errors you can look at, and you can drill all the way down to the type of defect, and boom, it even gives you a code set up where this defect happened. This kind of reporting is done every single day for the last year. I'm rolling all the way back to the top. I can go look at the PMD version of it, same kind of thing. And then I can see over time trending information. So I got a find bugs trend of how many things, failed versus warnings of PMD. The code coverage trend, I guess they weren't running their unit tests like they should have, but they were running their black box tests. How many of those things failed? It's relatively constant because we've been running this thing for the past year. There hasn't been any changes in this since April, obviously, although it's interesting that one of these failed just a few days ago, even though nothing's changed. But the point is you come in as a team and you'd start at your dashboard, something like this, and take a look at, did last night's build test fail or not? In this case, it's yellow. It's not green, which means good. It's yellow. That means that, well, there's some warnings associated with it and some potential things that you want to look at as part of the build. So you'd walk into your stand-up meeting and you could start with this and you could take a look at the test result and understand what tests actually failed out of something. All right. And there's several of these tools. So that's Jenkins, very popular. This is back to C dash. This thing finally loaded. Give you an idea of what what things failed, what kind of details are generated from it. Summary for it. There's probably a drill down. This is gives you outputs of the kinds of things. This is a C++ project. But the point is, just like our Scrum board, we have another dashboardy type of tool that can give us the overview of all our projects as well as into an individual project, and get a feel for, here's one that failed a bunch of times and then was successful. This is from last year. It has a little Chuck Norris plug in there too. I love that one. It can give you at a glance reporting and drill down capabilities for everybody on the team and even for all chickens, right? All stakeholders. So side by side with your Scrum board, you have another information radiator, but this one's focused on the quality of your product, all right, as opposed to the business value that's being built as a part of a Scrum board. You kind of hope that you're looking at your burn down chart and everything's going down, and you're looking at your quality chart and everything's going up. All right, that's kind of your goal if you lay out these two information radiators side by side. Okay. I need to erase that now again, of course. And that's because I don't have the right button. Sorry about that. I'm still getting used to my tools. Okay, so that gives you an idea of what a continuous integration and testing platform is like, and you will be employing one of these, and we're going to help you out with that. Finally, I want to wrap up. Instead of my own summary, I want to talk about Fowler's 10 best practices for continuous integration. This is still out there on his site. First, maintain a single source repository. Well, do you really want a single source repository? No, not really. Again, he drafted that before we were talking about the Gits of the world, where we had something that was more, peer to peer. But there still should be one what's blessed repository. Remember, we had those Git workflows, and we talked about a blessed repository, the place where if I had to go to and look at a repo, that represents our product. Um, Make sure you know what that one is, because that's the one you want to instrument with all this tooling to make the evaluation of quality work, right? So basically, it should be the one that represents your release. If that's master on so and so server or whatnot, wherever if it's master on GitHub, if it's master on somebody's box, wherever it is, everybody should know where it is the point. And on there, you should have a fully automated build. I should be able to click a button on a website and say, go build this, go run all the testing and tools that I want against it as I possibly can for my quality policy. Try and make your build itself self-testing. Um, Make it so everyone commits every day. Um, Again, in the Git world, that isn't necessarily the case anymore. But Fowler's point here is the more often you commit, the more often it kicks off a continuous integration process. And if you keep those steps small, again, you can embrace change. The real point of this is, as always, we are embracing change, right? And the key to embracing change is to keep that change small. If it's a big change, we have a harder time dealing with it. If it's a smaller change, we can actually deal with it faster. The rate of change and the amount of rework and impact it does, think of that exponential curve. Little changes, okay, a little bit of rework. Bigger changes, a disproportionately high amount of rework potential. Every commit should build the main line on an integration machine. That's what we're talking about. We should be building whatever the blessed repository is. So think of this as master. All right, on some integration machine somewhere. Okay, so something that represents putting all the software components together. Try and keep the build fast. If there is such a thing as putting too much stuff in the build, too many tests, too much automation, that it's not fast enough. When something's not fast, it means people are going to move forward. So keeping the build fast requires a balance of tooling and how much you're going to invest up front in infrastructure. A flip side of this is if you're doing something with an embedded system, anything hardware related, if you've got to go through a huge scaffolding exercise all the time just to build the software and test it, then continuous integration and testing just isn't going to happen for you. People aren't going to wait for things to happen. Do your best to test in a clone of the production environment. Again, a lot of defects can be environment specific. If you know computationally you're going to be running in a specific kind of environment, then that's what you should aim to test in. That's what you should have your developers work in if you can. We also talked about that in dynamic analysis, right? When you profile the code, so that what you kind of see are real concerns that can happen. Um, can't always do that, but again, a best practice if you can do it. Make it easy for anyone to get the latest executable. Nowadays, it goes forward even to automated deployment. And once something passes on the dashboard, and we get a green build out here, then all of a sudden we go, auto deploy an executable package to our release website. There's really mature or organizations that are really doing this well, are running things through their continuous integration and testing platform and automatically building a package and putting it out on their website every day with no human involvement. All right, drives us toward a concept of DevOps that folks are now quite talking about. Or folks might do some slight modification. You can go to a lot of open source sites and get the nightly snapshot, which will be labeled as unstable, which really means it's unstable because it's probably been fully automated through this process, and they don't designate it stable until they actually get a human in the loop to go look at it every week, every sprint, whatever it may be. Biggest big benefits here, can't emphasize enough. I just talked about automated deployment. This one, everyone can see what's happening. Again, can't say this enough. The fact that you have another information radiator, that I have a board that I can look at that now represents quality, right? I have quality. I have the Scrum board for value that I'm building. The Scrum board helps me with productivity as well, the task part of it. All right. The Scrum board helps with value, but really you look at the burn down chart for our story points. The fact that I can look at these and put them up on a wall and see them means I'm paying attention in my iron triangle to more than just um, uh, the value I'm building for release, but I'm also looking at the quality dimensions and the time dimensions. Okay. So that's it for continuous integration and testing. Again, I'm doing this as kind of a prep for getting your team spun up on a continuous integration and testing tool. We are going to help you with that. We're going to get that up and running, and when we do, really what your expectation is we're going to ask that you be able to add a tool to it. We'll set up the initial tools, and you can see by example how to do it. But then also to pay attention to it, meaning as you do your meetings in your team, as you do your retrospectives, and again, if you are following the best practice of doing stand-ups, even though I don't require them, that you should be visiting not just the Scrum board in your meetings, but now also visiting your continuous integration and testing dashboards. So in Sprint 3, we're going to introduce that. Don't worry, that's coming. There isn't anything in the lab that you specifically have to do for continuous integration and testing, but I wanted you to see this video, go through these notes beforehand, so when we introduce the CI and test platform for you next about a week's time, that you'll be prepared for what you're seeing. Okay.